Okay, class, this is our learning section, remote learning. Today we'll be covering section 3.4. So you should have this handout. So I'm going to follow this instead of the PowerPoint. So this is section 3.4. The PowerPoint went into some things that we're not going to go into. So I wanted to boil this down to the basics of what you need to do in order to graph polynomials. Okay, so we've spent time, we know how to factor polynomials, we did synthetic division. Now we want to get down to what it would be if we need to graph a polynomial. So there are a couple of things we need to know. First of all is end behavior. So the end behavior of a polynomial. So polynomials, there are very few things they can do as their end behavior. So for example, a polynomial can start up here. It can do various things, and then it either has to end up here. Okay, that's one choice. It can start up here. It can do various things and end like that. Okay, the other thing it can do, it can start like here at the bottom. It could do various things and movements and go this way. Or it could start at the bottom, do various things, and do this. These are the only four possibilities. So when you look at the end behavior of a polynomial, either both ends go up or both ends go down. Either it goes up to the right and down to the left, or down to the left and up to the right. Those are the only four things that can happen. And that is all controlled by the degree and the and the coefficient, the leading coefficient. So let's take a look, for example. Let me move this down a little bit. So it's all controlled by the end behavior, by the leading coefficient and the degree. So let's start out with an even degree. If I have a polynomial that is of even degree, then its end behavior, it's either going to point upward in both directions or downward in both directions. So if a polynomial, if the highest term is an x squared or an x to the fourth or x to the sixth, it's either going to go up in both ends or down in both ends. The way you can tell that is by looking at the leading coefficient. If the leading coefficient is positive, it goes up. If it's negative, it goes down. So what you can remember from what we did with the parent functions, this is the behavior that you expected when you saw x squared. Remember, x squared is either going to go up in both ends, or negative x squared goes down in both ends. Okay, so all the even polynomials, their end behavior is going to look like x squared or negative x squared. Now, if we have an odd degree polynomial, then it's got a choice. It's either going to go down to the left and up to the right, or up to the left and down to the right. So this behavior is going to be like what we saw when we graphed x cubed and minus x cubed. Remember, x cubed looked like this, and minus x cubed looked like this. Okay, so if it's odd degree and it's positive, it's going to go down to the left, up to the right. If it's negative, that's going to be flipped up to the left and down to the right. So we can look at polynomials in this case, and we can see what the degree is and whether that's positive or negative. So let's look, for example, in this first one. So both of these things point up. So I know that the degree of this has to be even. So this is, and I'll just go and write it here, this is an even degree polynomial. Since both of them point up, just like x squared, this leading coefficient has to be positive. If I look at the next one, it goes up on one end and down on the other. So this has to be an odd degree polynomial. Now, if it looked like x cubed, up to the right and down to the left, that would be a positive coefficient. This is flipped, so this coefficient is negative. If you look at the next one, it's going down and up, so it's mismatched, so this is an odd degree. And since it looks like x cubed, remember that's what x cubed looks like, this is a positive coefficient. The next one, it goes down on both ends. So that means this is an even degree with a negative coefficient. Looking on the bottom row, I see that this is an odd degree and the leading coefficient is positive. It looks just like x cubed, and the end behavior starts at the lower left and goes to the upper right. The next one is an even degree with a positive leading coefficient. Then we have an odd degree with a negative leading coefficient. And the last one you can see goes down on both ends. That's an even degree with a negative coefficient. So let's look at a couple polynomials. If I did not have the graph, what would I do? So what is the degree of this? The highest exponent I see is 4. So this is a 4, that is an even degree. Okay, so this is even. What is the leading coefficient? The number that is right in front of that x to the 4th is 3. That is a positive. So if I've got a graph that has an even degree and a positive coefficient, the end behavior is going to look like this. It looks like x squared. This next one is trying to trick you. What is the degree? The highest exponent I see is a 5. The leading coefficient is -2. So this is an odd degree. And since it's odd degree, remember, it's either going to look like x cubed or negative x cubed. And with that negative leading coefficient, ours is going to look like negative x cubed. So it's a negative leading coefficient. It's going to go up to the left and down to the right. Now look at the next one. What is the degree? So I've got an x squared term from this first parentheses and an x squared. When I multiply those, that's going to give me an x to the 4th. This is 4th degree. My leading coefficient, I've got a -2. Coefficient of that x squared is 1. X squared is 1. When I multiply all those together, I get a -2. So this is an even degree with a negative coefficient. If it's even degree with a negative coefficient, we know that it goes down on both ends. A few more examples. What is the degree of the next one? So I've got an x, 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 and x squared. So how many is that? So that's 2, 3, 4, 5. This is a fifth degree. Okay. The leading coefficient. How do I find the leading coefficient? Well, the first, that x squared is going to have a 1 in front of it. The next x has a 1 in front of it, a 1, and then that last 2x has a 2 in front of it. Multiply all that, the leading coefficient is 2. But what I really care about, that degree is odd, and that leading coefficient is positive. So if it's odd and positive, it's going to look like x cubed does. It's going to go down to the left and up to the right. 2x to the 12th minus x. The degree is 12. Leading coefficient is 2. So that is an even degree with a positive coefficient. It goes up on both ends. Okay. So we'll need that information when we come to graph a polynomial. So let's look at something that we need to graph here. So we need to graph f of x is x minus 1 squared times x minus 2 times x plus 1. What is the degree? So I've got this first term, x minus 1 squared, the highest order is going to be an x squared term. So x squared and then an x and an x. This is going to be a 4th degree polynomial. And the coefficient is going to be right in front of that x, you have a 1 and a 1. All of those x's have a 1 in front. So the leading coefficient is going to be 1. So the important thing is this is an even degree with a positive coefficient. So I know that it's going to look like this as its end behavior. Okay? Now to find the x-intercepts, okay, the other word for x-intercepts, we're going to use a lot of words for that. Those could be called the roots, the solutions, the zeros, okay? This is pretty easy when it's in factored form. Remember, if x minus 1 is a factor, then x equal 1 is a root or a solution. So I can look and see that 1, 0 is a root, 2, 0 is another root or x-intercept, and -1, 0. Now to find your y-intercept, remember the y-intercept is what you get when you set x equal to 0. If I set x equal to 0, then I'm going to get what? 0 minus 1 squared times 0 minus 2 times 0 plus 1. So 0 minus 1, that's negative 1 squared, that I get 1. So this is 1 times negative 2 times 1. This is just negative 2. So the y-intercept is going to be the point 0, negative 2. Now multiplicity, you need to look and see, this is fourth degree, but multiplicity says, is there a root or a solution or zero that occurs more than once? And you get that information just by looking at that exponent that you see right here, okay? Raised to the second power. So I know that there's a multiplicity, and the way I say this, there's a multiplicity of 2 at x equal 1, okay? So it tells me that this root right here occurs twice. Now graphically what that means is, if the multiplicity is even, I do not cross the axis, okay? So anytime you see that x minus 1 squared, it tells me that at this point right here, I will not cross the axis because that's x minus 1 squared. So now let's go to graphing this. So if I want to graph this, let's just graph the points. What I'm going to do, I'm going to choose green is where I cross the axis. So let's just look, for example, I know I'm going to cross the axis at 2, 0, so I'm going to put a green dot there, and at negative 1, 0. Okay, that is where I cross. According to this multiplicity at x equal 1, I do not cross the axis. So let's put a red dot at x equal 1. So I do not cross the axis. Where is my y-intercept? My y-intercept is at 0, negative 2. Okay, so right there. And I know that this end behavior that I see right here, it's going to start up and it's going to go down. So let's now graph this. So if I want to graph this, I know I have to start up here. And so is it possible to go through this point, not cross here, go through here and end up there? So there's only one possibility. So the graph is going to do something like this. And then it's going to go up. It cannot cross at that red dot, but it has to cross at the next green dot. That is the only thing this graph can do and behave just like your end behavior expected. Has the right x-intercepts and the y-intercepts, and the multiplicity just tells me because that's raised to the power of 2, which you see right here, I do not cross at x equal 1. So anytime you're looking at multiplicity, even multiplicity means I do not cross the axis. Odd multiplicity, I do cross the axis. So for example, if I had f of x equal x minus 1 times x plus 2 cubed, then this would be a multiplicity of 3 at x equal negative 2. And I would cross the axis because that's an odd multiplicity. And that would also, I would cross at x equal 1 because that's implied, it's raised to the power of 1. Okay. Now if I had something like, if I also had x plus 3 squared, that would tell me that there's a multiplicity of 2 at x equal negative 3, and I do not cross the axis at that point. So that's how we use the multiplicity and the end behavior to graph polynomials. Let's do another few examples here. So what is the degree of this polynomial? So if I look at that, we'll say that this is, if I have x, x, and an x, this is a third degree polynomial. What are the coefficients? I've got a negative in front of everything, so I've got a negative, and then in front of that x there's a 1, the next x has a 1, the next x has a 1. Multiply all that together, you get negative 1. So odd degree with a negative coefficient. That end behavior is going to look like this. It's going to start at the upper left, and it's going to end at the lower right. What are the x-intercepts? I like to do that before the y-intercepts. So -4, 0, -1, 0, and 1, 0. Is there any multiplicity? No, I don't see any of those raised to the second, third, fourth power. The y-intercept, you find the y-intercept when you set x equal to 0. When I do that, I will get negative. And let's see, I get 0 plus 4, 0 plus 1, times 0 minus 1. So that's -4 times 1 times -1. That is equal to 4. So 0, 4 is the y-intercept. Now, since there's no multiplicity, I know that at every point that I just talked about, I will cross the axis. So let's just change that to green. So at -4, 0, cross the axis, -1, 0, 1, 0. The y-intercept is 0, 4. Okay, I know that I need to start this graph. I need to go up. So I need to start it like this is the end behavior here. And then the end behavior here is going to go down. So it's going to need to cross through all of these points. Okay. Now this is a rough drawing. It's possible that, the graph, instead of going up to this point, maybe it goes higher and come down. That's possible, but you've got a good rough graph that shows you end behavior every place that it crosses the x and y axis. So that's a good representation of what this graph does. Next one, what is the degree? So I've got an x squared, an x, and an x. That makes this a 4th degree polynomial. The leading coefficient. So I've got a negative in front of everything. And let's see that I've got a 1 in front of that first term, a 1 and a 1. That leading coefficient is -1. Even degree with a negative coefficient. That means this is my end behavior. It goes down on both ends. My x-intercepts are 1, 0, -1, 0, and -2, 0. Is there any multiplicity? Well, yes, there is a multiplicity of 2 because of that exponent at x equal 1. So that means that I do not cross the axis at that point. So I can go ahead and mark that. So at x equal 1, I know that I will not cross the axis. And the y-intercept, how do I find the y-intercept? Remember, the y-intercept is what you do when you set x equal to 0. So if I set x equal to 0, I'm going to get negative of -1 squared times 1 times 2, and this is going to be -2. So 0, -2 is going to be the y-intercept. So I have everything I need. So I'm going to use the green dots. Where do I cross the axis? At -1, 0, at -2, 0, and my y-intercept of 0, -2. Where do I not cross the axis? I do not cross at x equal 1. Okay. So in graphing this, my end behavior, I'm going to need to go up right here. And so can I cross here, cross here? Let's just check on something real quick. I may have made a mistake. Yeah, you can see I got into trouble. I was drawing this graph and I was like, oh, I can't, once I got to this point, I need to go to the y-intercept. Well, I can't do it without crossing again, but there's no more x-intercept. So that means I made a mistake. My mistake was the end behavior. I did the end behavior wrong. This end behavior, it starts below, so it's going to have to do this because I already figured that out. So it's going to cross, cross, go up here. It cannot cross, and then it has to come back down. So that is the only thing this graph can do. So if you start to get in trouble when you're drawing the graph, look at your end behavior, look at your y-intercept, see if you've made a mistake, which is the case of what I just did there. Now we want to graph another example. X cubed minus 7x minus 6. So graph f of x equal x cubed minus 7x minus 6. Now, in order to do this, I'm going to need it to be factored. It is not factored, but we spent time in previous lessons knowing how to do this. So if this is to factor, so what are the possible factors? So the possible factors are going to be plus or minus the factors of 6 divided by the factors of 1. So that's 1, 2, 3, 6 over 1. So this is going to be plus or minus 1, 2, 3, or 6. Okay, those are the possible factors of this polynomial. So let's start with 1. If I factor out a 1, then I've got 1x cubed, 0x squared, negative 7x minus 6. So this is my x cubed, my x squared, my x, and my constant. Synthetic division, bring this number down. 1 times 1 is 1. Add 0 and 1 and you get a 1. 1 times 1 is 1. Negative 7 plus 1 is negative 6. 1 times negative 6 is, did I do that right? 1 times negative 6 is negative 6. That's negative 12. This does not work, okay? So let's move on to negative 1. So let's try negative 1. So negative, bring the 1 down, negative 1, add to get negative 1, multiply here, and you get 1, you get negative 6. Negative 1 times negative 6 is 6, add to get 0, so that is correct. So f of x equal, so if x equal negative 1 is a solution, that means that x plus 1 is a factor. So this is x plus 1, and then you read this information right here, times x squared minus x minus 6. Now this becomes, can I factor this? Are there two numbers that multiply to give you a negative 6 and add to give you a negative 1? So the only possibilities are 1 and 6, 2 and 3. The only way to add them and get a negative 1 is when the 2 is positive and the 3 is negative. So this is f of x equal x plus 1, x minus 3, x plus 2. So that is our complete factorization. X plus 1, x minus 3, x plus 2. Now, I can use that information to graph the polynomial. What is the degree? Now, I've got these two forms side by side. I've got the standard form and I've got the factored form. Now, having them both side by side is pretty advantageous. Some things are easier to read. The degree is 3. Don't ever miss that. All you have to do is look. The degree is 3 right there. If you were to get it from factored form, it's x times x times x, and that's how you get a third degree. Leading coefficient, what is in front of that x cubed? That's a 1. So odd degree, positive and positive coefficient, that in behavior is going to be like this, okay? The y-intercept is what you do when you set x equal to 0. That is easiest to do in this first equation, okay? Because if x were equal to 0, so if x is 0, I would get 0 minus 0 minus 6. So y-intercept is 0 minus 6. So it's basically, all it is copying that number down right there. That's how you get the y-intercept from standard form. Now in factored form, you would have to plug in a 0 here. You would get 1 times negative 3 times 2 is -6. You would get there the same way, but there's a possibility of making math mistakes. So I've got the y-intercept, x-intercept. That is what you read directly from the factored form. So if x plus 1 is a factor, -1, 0 is a root. 3, 0, and -2, 0. Is there any multiplicity? No, I don't see any of these roots raised to a power. So now I can know I can graph it, and it's going to cross at each of those points. So at -1, 0, at 3, 0, and at -2, 0. My end behavior is going to go down at the bottom and up at the top right. Now what is my y-intercept? 0, -6, right here. So it's going to have to start at the bottom, go up. So this graph will do something like this. It has to go up, has to come down through this point, and there we go. So that meets the end behavior. It goes through all the x-intercepts and the y-intercept. So the key was having it in factored form in order to graph the equation. And that should be it for this section.